Hey there, Mr. Wilford here. Just wanted to go through Chapter 7, Section 2 with you, all about ratios and similar polygons. And when we talk about two objects being similar, what we're doing is we're talking about them having the same shape but not necessarily the same size. And we use this symbol right here to indicate that two figures, two polygons, are similar to each other. You can see here, this is a good example of one triangle and two triangle. They are very similar to each other. They're not the same size. Obviously, one is bigger than the other. Here you can see that one is bigger than the other here, but notice they are not similar. This is right triangle here, and this one is not. So when we talk about similar polygons, what we're doing here, it says two polygons are similar polygons if and only if their corresponding angles are congruent and their corresponding side lengths are proportional. So really what that means when we talk about corresponding angles, if you line up the polygons kind of in the same order here as far as your how they look, then your corresponding angles, so for example here would be angle A and angle E, those would be corresponding angles. That they need to be congruent. They need to be the same measure, and then and that goes for all corresponding angles of both polygons. And then also the corresponding sides should be proportional. There's a proportionality between the corresponding sides as well. And we talked about proportions and ratios in the last section. So you can see here that we're talking about two triangles, and it says identify the pairs of congruent angles and corresponding sides. This is where you have to be careful because they'll try to trick you a little bit and flip some of these polygons around. Here they flip the triangles around. So we would want to say that angle Q and angle Y, those are the congruent corresponding angles. So you can go through and then you can look at some of the proportions here and just make sure that you match up. For example, XY has a length of 6, and then SQ over here would have a length of 9. So you can see they're proportional. So reducing the fraction would be 2/3. In the same aspect here, we would have YZ is 12 compared to QR down here, which is 18, and then again you can reduce the fraction there as well. So what we have here then is a similarity ratio, which is the ratio of the lengths of the corresponding sides of two similar polygons. So again, you kind of have to be careful how the triangles are written, or how the polygons are set up for you. And we can talk about this sort of ratio here. The similarity ratio of triangle ABC to DEF is 3/6, or 1/2. The similarity ratio DEF to ABC, notice that we're starting with the bigger one now, to ABC is 6/3. So the similarity ratio, it does depend on the order that you're looking at those triangles. So if you look at this triangle, or this example here, determine whether the polygons are similar. So first of all, again, notice that the angles here and the sides, you want to take note of that. And then if so, write the similarity ratio and the similarity statement. So what that means then is we are looking at angle P to angle T. Those would be the corresponding angles, and they're all right angles. So we're talking about these two figures being similar. And then we look at PQ over TU, again looking at these sides here, 12/16, reduce the fraction, PS over TW, 4/6, 2/3. Since the corresponding sides are not proportional, the rectangles are not similar. So you can take a look. Here's another example here where we have this similarity ratio is 4/3. So make sure you take a look at those. If you have any questions,